Now let's talk about some macro related features which we've added to COMOSYS in this version. So the first thing I want to talk about is that we had a lot of requests from our clients that they wanted an extra option in the angle cleat macros. So if you remember, the angle cleat macros would connect a beam to a beam with an angle cleat, or a beam to a column with an angle cleat, and the cleat would be welded to the secondary and bolted to the primary. Now our clients requested that we have an extra option of having bolts on both sides. So we've added that option in this version. So now we have the bolted to secondary side or welded to secondary side option. And if we choose the bolted one, then we can create bolts on both sides of the connection. The next thing which I want to talk about is the flange extension with cut macro. This is quite often used in the offshore industry. And what is needed is that you want to widen the flange at a certain area, at a certain point along the beam or whatever element it is, and you want to widen the flange because something is sitting on that. So for that, we have added this flange extension, and it's very simple to use. All you do is you select the beam, and then you select a point on the beam, and you can do that very easily with the direct entry method, as you know. So you can say dy 2000, and that'll give you a point on the beam from on the beam wherever you want, basically. And then you can put another one ahead of it, and when you do that, it'll create a flange extension at that point by cutting out the flange of the beam, and replacing it with a plate, one of the available thickness plates, and it will basically create this widened flange along between those 2 points. And what you can do, that you can go inside and you can change this distance 2000 to whatever number which you actually want. For example, so I can make it shorter, I can make it longer, I can make it left aligned or right aligned. As you can see over here, I can make it left aligned like that. I can put it in the middle of the two selected points, or I can make it right aligned with the other one. Let's make it middle for the moment. And what you can do further beyond this is you can have total control over the plates, the stiffness below. You can create as many as you want, and you can increase the width over there and all that. All these parameters are available over here. You can set your macro presets as always, and this is a very convenient way to widen the flange. We had a similar macro before as well, which is the normal flange extension, but this one actually creates two side plates. It doesn't really cut the flange, it adds two extra plates. This new one actually cuts the flange and inserts a plate at those points and gives you a widened. Now let's talk about the welded beam to beam fixed connection. This is very convenient when you have a beam to beam fixed connection. And normally floor beams, we have simple connections, but occasionally with cantilevers or things like that, we have fixed connections. And there are different ways to do that. We can either have a bolted one, but then typically the problem is that the size of the main and the size of the secondary is not the same. So the bottom flange creates a problem, and the bottom flange pushes in or out and actually hurts the web of the main member. What is needed is something which can sort of convert the incoming secondary beam into a larger size just when it is about to hit the main beam. And for that, we have developed the welded beam to beam fixed connection. This is also used in the offshore industry a lot. So all you do is you basically select the main beam and you select the secondary beam, and immediately you have this connection in which plates are used. The flange, the web of the secondary is cut out. So if I were to just show this one only, for example, you can see that the web has been cut out. And if I were to show all, again, a plate has been inserted in the location of the web in this way, and the flange has been extended, it has been continued in such a way that it hits the bottom flange of the main. Now, there is another option inside this macro. So let me connect another one over here. But there's this option if you go inside the macro, in which you can ask it to use either plates or the same profile itself if possible. So this one is with a caveat that it's not possible with certain sizes because of the angles involved. But if you use the beam option, then what it will do is it will use this very same profile. So this is an IPE 200. It will use a cutout piece of an IPE 200, and create that. It will widen it basically to meet the bottom flange of the main member. Once again, this is a very convenient option. You have your welds over here and over here, and now you have a fixed connection between the two beams, and there is no problem with the bottom flange pressing into. Another connection which is very popular in the offshore industry is the welded pipe bracing connection, as you can see in the icon as well. It's very common for large pipes, CHS profiles, to be coming in to the beam. And it's also not uncommon that the bracing profiles are actually wider than the beam itself. So the flange of the beam is narrow. So for the connection, the flange needs to be widened. And we just talked about the widening, the macro which does the widening. But here it's like a combination of this one and the normal connection. All we need is a welded connection between the two. And what it does is, what this particular macro does is, if I were to just select this one, for example, it asks us to select the beam and then the braces. So I can select the two and I can right click. And when I do that, you can see that it widens the flange according to the need, and it creates a welded connection between the pipes and the plate, which has been basically used as an insert into the flange. The flange has been cut out and a plate has been inserted to widen it, and we have as many stiffeners as we want below. It's a very the interface is complete, and we can basically have as many of those plates as we want, and we can give it whatever width that might be needed in the circumstances. But the idea is that you can just directly connect your welded braces to the beam, no matter how wide they are, because it's going to widen the flange anyways. And that's a very convenient way of creating this connection. This, like I said, once again, is very popular in the offshore industry. Now let's talk about some pre-engineered building macros which we have developed in this version of COMOSYS. Now, as you know, pre-engineered buildings are very common. They're very commonly used throughout the world, and there are certain connections which are repeatedly used in these types of structures. And one of them is the purlin connection, in which the Z profile is used. And the connection is basically can be explained like this: that the Z profile is extended on each side, and then they're connected by bolts and a plate. And then we also have sometimes we have struts to basically connect to the bottom flange of the supporting beam. Now, very simply, what we can do is we can use the normal purlin connection, select the main beam, select the Z profiles, and we get our standard angle connection, or whatever the default is. But if we go inside the macro now, we have this option of the overlapped Z. And if we select that, you will see on the screen, if we select that, immediately an overlapped Z connection is created. And what that means is that this purlin is extended to the other side, the other one is extended into the first one, and we have a plate connecting the two with 4 bolts. But then there are other bolts as well, which are just connecting the two purlins to each other at these points, according to the need. And what we can do with these now is, if I press the M enter button, I can go to the Z purlin tab, which is new, and I can actually ask for these struts to be created. And these struts will automatically change the IDs of the bolts as well. And if I do that, immediately those struts are created on either side of the connection. And now, since the bolt IDs are different, so this is a single bolt now because it's going through the strut as well, and this is a separate bolt. These two are one ID, and these 4 are one ID because they're going through the plate as well as the other one. So this is a very handy way of creating this new purlin, Z-type purlin, overlapped purlin connection, which we have now added to COMOSYS for in order for the connection of, or for the creation of pre-engineered buildings. Now let's talk about another macro which is used in the pre-engineered buildings sector, and that is the tapered end plate splice. And it's very common to have elements which are tapered, and one of them is tapered, the other one is straight, or both of them are tapered. And you need an end plate splice connection for such situations. So what we have developed is what you can see on the screen, the tapered splice connection. And all you need to do is just select it, select the first member, and select the second member, and immediately your complicated end plate splice connection with all the options of creating bolts in the different locations and the stiffness is created for you. This is very convenient, very easy to use, and it can be used not only for columns but also when you have some similar situation in the. Let's continue with more pre-engineered building connections. So another situation which is very common is for these wind columns on the facade to go and hit the roof beam, and over there we have connections from the bottom side to the bottom flange of the roof beam. And for that we have developed this PEB end plate to flange connection, and this is very simple to use. All you need to do is just select the main beam and then select the column, and once you do that, immediately this connection is created. The bottom flange is cut out and this plate replaces it because widening is needed at times. And another end plate is given at the end of the column. And you can have complete control over where the bolts are and whether the stiffener will be created or not. But this is very convenient connection, allows you to connect the column to the bottom side of the beam when the column is facing in this strong direction. Now, it is also possible that the column is not, the strong direction of the column is along this line rather than perpendicular to the beam. And this kind of situation is also possible. So the same macro works for that case as well. Once again, just select the beam and the column, and the connection is made with the same style. You have different styles inside. I didn't open those up to show before, but you can have the option of two-sided plates or one plate which with the bottom flange cut out, or you can have two plates at the sides as well. So once again, a very convenient way with complete control to create your PEB end plate to the flange connection. Now, moving on with pre-engineered buildings, we come to this very important connection between the column and the beam. And this is perhaps the most important connection of the structure. It is a moment connection, and it is done in different flavors and different styles. And usually we have very large panel zone shear forces in this area as well. So we've developed the knee connection for this case, and it's very simple to use. All you need to do is select the column and then select the beam, and immediately a very well defined connection is made. And what if you can see, because of this panel zone over here, a lot of times the thickness of the plate is not enough of the incoming beam, so you need a thicker plate over here. So this one basically cuts out the web of the tapered member in that area. So if I were to just show that one, for example, if I say show only, you can see that the element has been cut out like that. Let me go back to showing everything, and a plate has been put in there in place of the web, and it's a thicker plate than the web, and you can obviously change the thicknesses according to your need. But this one basically creates this connection, puts in the stiffeners. You have complete control over the bolts. You can even have this little extension over there depending on where your purlins are, and you have, like I said, complete control over the bolts as well. So this allows you to create this very complicated connection with a few clicks. You replace the web of the beam, you replace it with a thicker plate, and you have a working connection for this kind of situation, which is very common in PEB type structures. Now, another way of doing this connection is to, instead of cutting the web out and replacing it with a plate, you can also have doubler plates. So you can let the beam run through, and you can have two plates on the back and front side, and that's the doubler plate option, because basically, like I said, you have these high stress shear stresses in this area. And in this case, we have another option. We can use the column and the beam. Instead of cutting the web, so this, if I just show this only, you can see that the web has not been cut. It continues till the end. But what we have is these extra plates which have been added, and these are doubler plates, and they've been welded to the web to thicken it in that area. And this very convenient option then allows you to, and the stiffeners have been modified according to that, to basically reduce the panel zone stresses. But that's not all. There is another way of doing the same connection, and once again, let me go in and choose the column and the beam. And this time what we have is the diagonal stiffener. This is another way of making the same, of reducing the panel zone stresses. You basically put in a diagonal stiffener from end to end, and we have complete control over the geometry. And the good thing about this is that instead of 3 different macros, all of them have been collected into this one single macro, and within that macro you have these options of creating this diagonal stiffener or doubler plates, or basically the removal of the web and insertion of a thicker plate to take care of those um, high stresses. So this is a very important macro which we've added. It's called the knee connection, and it is there for, like I said, the pre-engineered building sector. And this connection is everywhere. It's rampant. And if you can see with these new features, we can easily now connect our pre-engineered buildings very quickly with the knee connection, with the Z overlapped Z purlin connection, with the tapered splice connection, and all the things we've talked about. We can easily now very quickly go through our pre-engineered buildings. Now, after having gone through these major improvements, which really make the modeling of pre-engineered buildings very easy and very fast, let me also talk about some minor changes we have made in some existing macros. So previously, the base plate macro only worked with non-tapered sections, but what we've done now is that you can use the same base plate macro with a tapered column, and once again you can create the base plate very easily. Another very important improvement which we have done is that now the bolted gusset and the gusset macros in general, they also work with the tapered profile. So here you see that the bolted gusset macro has been used to connect this roof bracing to the tapered profile. Previously, this was not possible. You needed to do some things manually. And now you can very easily just use the normal bolted gusset connection with the tapered elements, and your macro is done very quickly for you. Similarly, your girt macro and the other options for the girt and purlin macros now also work. All these options now also work for tapered members. Whenever the tapered member is the main member, previously you could not connect using these macros, but now you can with the new version of COMOSYS. So that is a brief summary of the macros that we've added in this new version. As you can see, we've talked about a lot of macros regarding the offshore industry, regarding the pre-engineered building sector, general improvements and all. There's a lot we have done in the last 6 months, and the user will be much more satisfied with the new version. And we've been listening to our clients, like I said, but this was a brief summary of only the macros which have been added to COMOSYS. And as you can see very easily, these will really help you get your modeling done much faster.